I've received a couple of questions on experiments. What is a natural experiment? What is a quasi-experiment? What is an RTC? That I decided to do a quick video on this. I would like to add, though, that it's not a key aim of this course to be able to tell, for instance, the difference between a natural and a quasi-experiment. The key aim is to be able to say, look, these are the characteristics of a true randomized controlled trial. This is proper randomization. We have identified a causal effect versus a situation where a setup doesn't quite live up to these requirements and thus turns out to be a quasi experiment, not quite a true experiment. That's the key goal. Just to reiterate, what is it that an RTC is? First of all, we are really keen on this randomization. We need a randomized allocation to each treatment. We start out with a bunch of people, whether they're all male Harvard students, as in Dana Riley's study, or Chinese factory floor workers, or whatever they are. We just want to try to make sure that they are as similar as possible after the randomization. We know they're not going to be completely identical. People, companies are different, but we want them to be as identical as possible. We could even do some post-tests where we, for instance, make sure that there's an equal number of men and women in each group that have the same age, etc. Okay, so we want this randomization to have worked out. And we want the two groups to be as identical as possible, and we want this to continue to be the case. And we also want them to be in as controlled and similar environment as possible. We know that if we put people into different classrooms and, for instance, change the teaching styles, that while the classrooms might be slightly different, but so we're going for this aim of having no systematic differences between two different settings. And we want these very controlled environments because we might want to make sure that the two different groups are similar as possible, in as similar environments as possible, and only exposed to one particular treatment. Whether it's how they build bionicles, or whether it's the curtain, or whether it's the time of the day where they engage in tests. Any kind of treatment we could imagine, to make sure that there is only this one difference between the groups that we have in mind. And in a quasi-experiment, what we are then trying to pay attention to is to say, well, okay, we realize in the elementary school example about cognitive fatigue, for instance, we realized the allocation wasn't randomized as such. It was people employed at various schools around the country that tried to make sure that there was classrooms available, IT equipment available, and that's why sometimes it was 4A that had the early time, and sometimes it was the class 4B that had the late time. But we could then argue that the process was as good as random because kids didn't self-select into, I want to do the early one today, or school teachers didn't self-select their classes into certain times of the day. It was just as good as random a process. And again, in a quasi-experiment, if it doesn't happen in the lab where we have complete control over everything, we can't be 100% sure that there is only this one difference. But hopefully, in the end, we'll have been able to identify the one key factor. So to take the example of the Spanish flu example again, we had the Spanish flu example where on the x-axis have how quickly cities, and each circle is a city, how quickly cities responded to the crisis and closed down schools. On the y-axis we have the impact that the flu had on mortality in the given cities. We see a fairly strong correlation here, 0.37. That's far stronger effect than the headache pill has on the reduction of headache. Question is this a quasi-experiment? Can we say that there's only this one variable that makes Pittsburgh and New York and St. Louis and Chicago, etc. different? Well, actually, if we look at the original study, we can clearly say no. There were some interventions that the city could engage in, and there were school closure, cancellations of public gatherings, isolation and quarantine. So there were actually different things in play here. There wasn't just one variable that distinguished these different cities. So in an RTC, we can actually claim, look, it's only this one thing. In the elementary school example, since We had a large data set, and since it wasn't the kids themselves that made any kind of decision, we can be reasonably certain that this is the key factor, the time of the day they took a test. But in this example, what we can pay attention to is that it was clearly cities themselves that could self-select whether their own school should be sort of in the one treatment or not. And that also makes it clear that there could be lots of other things that we don't know about. Again, we could go to the original study and find the true answer here, but already in principle we could be a bit more uncertain about this. So in any kind of sort of naturally occurring experiment, whether it's in elementary schools or the Spanish flu, try to pay attention to who are these people or schools or cities or companies that are in different treatment groups. How did they get there? And in a natural experiment, it's simply then defined by it was something that happened in nature. And the elementary school example is then not quite clear on that. I mean, it wasn't researchers that did it, but yes. So, and just then to showcase something that clearly is something we would call a natural experiment. It's not quite a true randomized controlled trial in the sense that we can't be 100% certain that there wasn't some kind of systematic factor. Not 100% certain like when we flip a coin in a lab. What we do notice here in this example that we saw in Study Cafe 1, that there was variation in the amount of nuclear fallout caused by the Chernobyl disaster, and there was this regional variation. And the regional variation depended on rainfall. It turns out that depending on how much rain a given area got, it got more nuclear fallout, and this then leads to variation in standardized cognitive tests 25 years later. I have a longitudinal data set. Seems to be a treatment, and the treatment is how much nuclear fallout do you get as a person living in Germany at that time. As I said, I lived in Germany there in '86. So it's not a formal randomization process, but I think it's a situation where we can be fairly certain that this probably is as good as random. The link between cognitive ability and variation in that, and whatever happened sort of earlier in time, it does seem like that we can say that the Chernobyl disaster was a key factor. The regions, the various areas in Germany, they didn't decide themselves whether they should get rainfall or not. It was an external shock. It was an external factor, which is why we can call it a natural experiment. We would still usually call it some kind of quasi-experiment because, again, we can't be absolutely 100% certain that there isn't some kind of relation between whether you're in an agricultural area or whether there could be any other systematic reason for why cognitive ability is linked to these different regions in the way it is. So again, natural experiment, it's something that sort of happened outside the researcher's control, often in nature. In this situation with the rainfall, we can consider it basically as good as random, but we still do prefer, like in a proper randomized controlled trial, to have absolute control of the situation and be certain this group got this treatment, that group didn't get the treatment, and there's only one difference between these groups.